afternoon, everyone. I, Ishan Desai, along with Professor Ruchi Patel, welcome you to the webinar on Building Energy Management System, organized by Electrical Engineering Department, Parul Institute of Engineering and Technology. Today we have with us Mr. Keval Velani sir, who is currently associated with Hitachi ABB Power Grid. Sir has done his graduation in the field of electrical engineering from BVM Vallabh Vidyanagar. Then he has joined Takalkar Power Engineer and Consultant and he is associated with that particular firm till January 2020. Then he had joined ABB Power Products and System Limited, and since February 2021, he is associated with Hitachi ABB Power Grid. Sir is having vast experience of more than 9 years in the field of power system and substation designing, and he is a Lean Six Sigma Yellow Belt holder, and he is also member of many reputed societies. Uh, Through today's webinar, participants will be able to learn or understand so many things related to the topic. So before we begin with the webinar, one small thing that I want to tell is if you have any query, you can send it through mail on ishan.desai@paruluniversity.ac.in. Again, I am repeating ishan.desai@paruluniversity.ac.in or through WhatsApp on 9978559436. Again, I am repeating 9978559436. So, without wasting much time, I am handing over this session to Keval sir. So, Keval sir, over to you. Keval sir.
Yes, thank you, Ishan, for this wonderful introduction. Am I audible?
Yes, sir, you are audible.
Okay, thank you so much. Thank you once again, Parul University and Parul Institute of Engineering and Technology for giving me this opportunity for our expert talk on webinar on building energy management system. Please confirm my screen is visible or?
Yes, sir, it is visible.
It is a full screen or presentation mode?
No,
or
just a presentation.
Okay, so hope now it is on the
yes, it is
mode.
Full screen now.
Okay. So thank you so much and welcome you all participants webinar on building energy management system. So this is myself, Keval Velani, working as a technical consultant at Power Consulting Division of ABB Power Products and System India Limited. And these are some ground rules related to this webinar. Please be familiar with the place from which you are attending this event. In case you are at home, take care of all aspects of working with safety from home. This technical event is designed by APPSIL. No content of this presentation shall be copied, recorded, or reproduced without the written consent of APSIL. You are muted. However, if you have any question, feel free to type in the meeting chat, or as Isan said, you can directly mail on Isan email ID or on his WhatsApp number, or alternatively you can write an email on my email ID keval.velani@hitachipowergrids.com. I will reply at the end of session or after the completion of the session or day after tomorrow. So this is the flow of webinar of today's webinar, building energy management system. First of all, we are talking about the carbon footprint and carbon emission reduction. Then why building energy management system required within our day-to-day life, within our nation, and within globe. Classification of energy efficiency, factor affecting building energy management system, and building energy management system application. What are the applications where you applied this building energy management system? And at the end of this webinar, we will discuss about the case, one of the case study which we work out related to building energy management system. So first of all, we start from carbon footprint and its emission reduction. This is our as a Hitachi ABB Power Grids, our goal, future goal, neutralization of the carbon emission and energy system. By 2050, energy will be the backbone of the entire energy system. It means each and every field within the nation, within our day-to-day life cycle, and within the globe, nothing working possible without the electricity nowadays and in upcoming future days also. Electricity demand will be more than double by the 2050 within the globe or in our day-to-day life cycle. All market sectors, now you aware about this, all market sectors like textile, industrial, chemical, and all market sectors converting towards the electrification. It means towards the digitalization, towards the cloud based system, automatic system, and it is a part of the industry 4.0. So effect of this digitalization, electrification market sectors, electricity demand will more than double by 2050 in compared to our present power demand. And digital and energy platforms are needed to manage after the use of an increase or increment of the electricity demand. We have to manage our day-to-day carbon emission footprint or carbon emission reduction. We have to manage our carbon emission reduction. So we will talk about this. Can we carbon emission reduction? Yes, we have to do, and we will, for our upcoming lives, for our upcoming childs, and for our upcoming generation. This is must and this is requirement. That's why we talk about this carbon emission reduction. We can and we will carbon footprint reduction as an individual, in my life cycle, as an organization, as a nation, and as a globe, can be reduced. Yes, we can reduce carbon footprint, life cycle, and health. So this is the one step towards the healthy future with reference to carbon footprint emission reduction. And yes, this is the some proof of the news cutting, and we have to, and this is the 10 ways to reduce your carbon footprint in day-to-day life cycle. Like one of the planting trees, used LED bulbs or energy efficient bulbs, then some of the carry bags used as a reuse bags, used as a minimum micron capacity, use your clothes in cold water, fly less, go local, then unplug applications when they not in used. Adjust your thermostat. You can reduce your carbon emission with the monitoring or with the reduction or with the setting of your air conditioning system or your heater system, and take shorter showers. So this is the some examples of the 10 ways to reduce your carbon emission within your day-to-day life. Here you can see one small documentary related to the why building energy management system required. So here you send one small documentary related to the smart application within your home premises, within your industrial and commercial premises, within your public utilities, within the commercial buildings. Why this smart application required, and it will helpful in the reduction of the carbon emission. This smart application also we have to use because of the digital technology and building energy management system required with these features like efficient workplace, more sustainable energy system, high quality living system, very high safely system and workplace, more reliable 24 by 7 power and more reliable power network, either it is a transmission system or distribution system, and 24 by 7 continuous power. So this is the features added in building energy management system. That's why we need this type of energy management system within our building area. This is the equipments. Here you can see some home appliances, commercial appliances, and appliances, all equipments. And this is the edge intermediate system which we can use as a operating system or operation and maintenance system. Here you can see device edge and cloud. With the using of edge and cloud, we can operate our home appliances and our day-to-day life equipment as we are using this equipment. Means if you want to on off your home appliances or any equipment according to your requirement, you can operate with the using of cloud. And when you are not using any equipment, you can do as a switch off. So this is the facility. And in building energy management system, coordination of these three department means three facility: device, edge, and cloud. Coordination and interface within these three facility must required in building energy management system. Here you can see building energy management system. Why required? Because it is required smarter, safer, greener, efficient, and comfortable system for whom, for what it is used for: customers, employees, and our family. Someone said management is all about art, science, craft, and technology. So building energy management system is combination of art, science, craft, and technology for the application of customers, employees, and family. Energy flows in the building. What are the three milestones? What are the three milestones for energy flows in the building? This is the energy flows in any building: energy transparency, energy management, and energy efficiency. This is energy transparency creates the databases for actions, reactions, and improvements. Parts of the operational management and analyzed with the precision in practice, measuring, evaluation, and data management. Our second milestone is energy management. How to manage energy within our building premises. Organize and systematic coordination of procurement, conversion, distribution, and usage of energy. It means incoming power, outgoing power, power demand, and usable and used power, means actual power of our building. They these all power parameters need to organize, and systematic coordination must required in building energy management system. And one of the most important, to meet technical and economical power requirement. It means our incoming power and outgoing power and our managed power sufficient application requirement to our usable, technical, and economical requirement within our building premises. Our third milestone is energy efficiency. How we maintain energy efficiency within our building premises, the relation between energy outlay and resulting benefits. The ratio of power input in relation to the effective power output means your incoming power and outgoing power ratio of both, it's in relation within the output power evaluated over a defined period of time means you have to evaluate your day-to-day power consumption and incoming power. So this is the three milestones, important three milestone: energy transparency, management, and energy efficiency. Here you can see some basic block diagrams with reference to building energy management system. First of all, our three milestone: energy management, energy transparency, and energy efficiency. How here you we can see how it will connected within the system and each other interface required. This is the power source and power distribution. Both are covered in energy management and correlate and interface with incoming power and power distribution. It means power output. Energy efficiency correlate with the power source management and application. Means if you have approximate 10 megawatt power as a application devices, or in residential point of view have 10 kW or 6 kW as a application power load demand. So in against you have to manage more than 10 kW, or in industrial more than 10 megawatt as a power source you have to manage. It is a part of power source management. And now here you can see a coordination and interface within the power source and power source management, power distribution, and its application. Means according to the your home appliances, according to the industrial load, for as a motor, as a heater, as a boiler, you have to manage application according to the power distribution, and as per your power demand you have to maintain your quality of the input power, means quality of the power source, and you have to manage entire power source, means entire input power related to your output power, means as related to your power demand. And energy power source management and usage of application means usage of power demand, it is also interconnected with the help of energy efficiency. Means with maximum energy efficiency you have to maintain high efficient quality application or appliances related to your power management, power source, and power distribution. Okay, now here you can see these three all milestone: energy management, energy transparency, and energy efficiency also connected each other with reference to your power demand and power source. Also it is a interconnected. Energy transparency is also must with three all milestone and application and power distribution, and also connected with the power source also. So this is the basic block diagram how it is operate. Here you can see some basic power distribution network. Here you can see this is the power source, means renewable power source. This is generator, non-renewable power source, power distribution transformer, and power distribute to the sub distribution board, and then finally distributed to the individual application. Either it is a low motor, it is a heater, or your receptacles or lighting load. So what are the parameters you have to measure? What are the parameters you have to maintain as a quality power? So this is the typical recommended measurements for generator. You have to measure voltage of the rated voltage of the generator, rated current of the generator, active power, what are the active power feed by the generator, what are the energy kWh in terms of watt, and what are the apparent power in a kVA, and what are the cost by power factor. So this is the recommended measurements for particular generator. Now what are the in you have to measure as a current, because of you have to operate operation and control philosophy by this protection and operation system. And at the end of last you have to measure this all load side parameters in terms of lighting loads, receptacles, and other heater loads. You have to measure voltage, current, active power, and cost by power factor. In terms of motor load, you have to measure accurately measure current in ampere, active power kW, and cost by power factor. So this is the recommended measurements with the example of typical single line diagram of power distribution system within your building premises. Now, what are the measurements with reference to your daily demand, monthly demand, and yearly demand? Before design entire building distribution system, or before design building energy management system, you have to confirm your daily load demand, means daily demand as in kW, daily variations, what are the variations in power demand in morning, afternoon, and in evening, typical work shift patterns. Some of industries or commercial department or commercial buildings, some of the shift patterns, there are 3 shifts: morning, evening, and night. So you have to manage your daily load curve with reference to your shift patterns and demand peaks. What are the daily demand peaks? Means normally in afternoon 12 noon to 3 p.m. or 4 p.m. you can find as a demand peak. Next, monthly load curve. You have to check your similarities in power purchase, continuity at the weekends. You have to check what are the daily load demand and weekend point of view, and purchase the power overnight. It is required night power for the night usage of the power. What are the base load? Base loads mean what are the minimum load? Means your daily demand, mandatory demand, necessary demands. This is the covered in base load. What are the holidays, bridging days, weekends, and other operations close days? Or you heard or you heard about the some of the industrial zone. There are Tuesday off, Wednesday off, Thursday off. So you have to manage these holidays, bridging days, and operation close days before you decide or before you draw your monthly load curve. At the end of yearly load curve, what are the load patterns within your month wise power consumption, continuity over the months, electricity peaks at the certain points in time over the year. It means here you can see some seasonal effect in power demand. So you have to check your electricity peaks and down within your seasonal or seasonal capacity or seasonal power demand, and seasonal variation, operating holidays, and other special operating situation within before you draw your yearly load curve. What are the preliminary planning at design stage required in building energy management system? You have to decide type of the building, utilization of the building. Either it will used in as a residential, commercial, industrial, or special economic zone. What are the shapes? It is a part of the green building or not a part of the green building. So this is the these all parameters you have to decide before or during the planning stage of the building energy management system. Regulations and requirement. What are the rules at state level, district level, and national level? Regulations, requirement. The technical building equipment required for operation. Requirements of the distribution system operator. Then power demand, application, tariff, and connection cost within the your state utility and central utility. Possibilities of the distributed power generation. It is a possibility to install solar system or wind system, so or biogas system. So you have to check to this or distributed power generation before or during the planning stage of the building energy management system. Determination of the building related to the connection values depending on the supply area loads. Determinations of the load centers. What are the load centers? Means at what area of the building you have requirement, maximum power demand, minimum power demand, and regular power demand. Determination of the network load simultaneously factor, then utilization factor, specific area load for estimated, then what are your power factor maintenance, then the power system configuration, structure of the power system configuration, taking into the account with reference to structure of the supply area and purpose, number of load centers, size of the load center, and position of the load centers. Transformer arrangements, how distributed transformer or how you manage power demand within the distribution transformer. So this is also most important in building energy management system, and you have to decide these all parameters during the planning stage. Routing, what are the cable routing with distribution system, and what are the voltage level you have to require, 415 volt, 11 kV, 22 kV, or 33 kV, or 6.6 kV. So you have to decide during the planning stage before the application of building energy management system. What are the rating and selection of the electrical equipment? Switch gears means MCCB, MCB, ELCB. These all switch gears rating and applications you have to decide during the planning stage of this BEMS system. Distribution transformer, cross section of the conductor, sizing of the cable, sizing of the conductor, sizing of the all electrical equipments, motors, firefighting system, VMS, visual monitoring system. These all electrical equipment you have to select particular size and rating of the equipment during the planning stage of this energy management system. What are the classification of the energy efficiency in application of building energy management system? There are 4 types of the classification: A, B, C, and D according to the European standards. In A classification, highly energy efficient devices and system installed in energy management system, EC fan, LEDs, transistors and converters, regular maintenance, possibility with remote monitoring, extensive communication and control options. Means in A type of the energy efficiency classification, all equipment used as energy efficient devices and system, all equipment operate automatically, remote operation, and control and communication within your requirement or not requirement. In terms of the B type of the energy efficiency, improved efficiency devices and systems, extensive communication and control operation. It means improved energy efficiency devices. C classification, standard devices, means used as a standard equipment, not highly energy efficient equipment used in C type of the energy efficiency classification. State of technology during operation, no communications options, only mechanical adjustment. It means no auto operation mode available, only manual operations available in C type of the classification. Last, D type of classification related to energy efficiency, simple device, normally on and off, functionally only on and off, no any remote operation, no any manual operation, only switch on and off, no any other fine tuning. These all equipments covered in D type of classification. Here you can see function list and assignments related to European standard EN 15232. Here you can see basic performance classes A, B, C, and D. A means high energy performance, B means advanced, C is standard, and D is non-energy efficient equipment. So this is the here BSCS is building automation and control system, and TBM means technical building management system. In A type of the classification, B building automation and control system and technical building management system both are installed, and B type ma both system are installed, but it is a minor system, not highly efficient. In C type classification, only building automation and control system installed, and D type ma only building automation and control system with non energy efficient equipment. Here you can see classification distribution with reference to application: heating and cooling, ventilation and air conditioning control, lighting system, and sun protection. What are the usage of the natural lights? What are the usage of the natural winds? These all parameters covered in energy performance classes with building automation, controls, and building managements. There are energy performance of means large impact of these parameters in building performance or energy performance of the buildings. Here you can see some of the calibration factors related to class and particular area. Calibration factors for the technical equipment and buildings related to the building automation and technical building management related to these European standards for commercial and public utility building. Here you can see the energy efficiency classes A, B, C, D, and typical calibration factors for offices, auditoriums, educational facilities, hospitals, hotels, and restaurants. These all applications of calibration factors we can see in upcoming slides as a case study and applications of building energy management system. Here you can see typical energy distribution network sizing factors related to building energy management system. Load flow calculation, you have to do a load flow analysis after the designing of typical power distribution network. Short circuit current calculation, you have to perform short circuit current calculation or short circuit analysis after the load flow analysis. Economical analysis, what are the savings you have to save or you can save in design distribution power network. Sizing of the switching device, what are the sizes of MCB, MCCBs, ELCB, ACB, what are the sizings of the conductor. Protection analysis, what are the protection you provide within the design distribution network. Arc flash analysis within particular short circuit in the distribution network, single phase short circuit, three phase short circuit, and power quality. Power quality means you have to maintain particular threshold voltage, current, and power factor. Load reduction factor, what are the load reduction factors? Simultaneous factors, these all factors covered in load reduction factor. Safety aspects, you have to safety keep in mind during the design practice. All safety aspects covered must you have to cover within this application in building management system, and you have to provide n-1 and n-2 level contingency. Means if your one power network maloperate or in faulty condition, so you can provide a second source of power for particular equipment and particular appliances. This is known as a n-2 level. This is the entire feed analysis, means how you can or you will feed power within your power distribution network or to your particular equipment or appliances within your home premises, industrial premises, or commercial and college, hospital, and public premises. So this is all distribution factors keep in mind whenever you design distribution network. Here you can see some small documentary related to the building energy management system. How you can reduce your energy savings, means how you can save your energy savings and reduce carbon emission. It is a typical representative documentary. In your classrooms, you can automate presence detection. In office also you can detect presence detection. If you remembered our three milestone: energy efficiency, energy transparency, and energy management. Transparent energy consumptions, intelligent energy controlling. So here you can see our four major parameter: presence detection, constant light control, sun blind control, and climate control. So with using three natural and total four parameters, you can save your energy demand, or you can reduce your energy, you can reduce your carbon emission footprint. How you here some snapshots of the software platform related to the electrical distribution control. In first image you can see a smart dashboard, each and every equipment rating, what are your daily load curve, monthly load curve, yearly load curve, and what are the power demand, peak demand, time wise, slot wise device, each and everything you can see your smart dashboard. This is the typical snapshots of software with the application of building energy management system, intelligent control system within your computer premises, within your location, within your office sitting area. You can operate and analyze entire electrical distribution system with intelligent control system. Equipment summary: what are the equipments now connected as a off on and as a off condition, with application and with operation philosophy. This is the equipment summary. Individual power demand: what are the individual power demands with reference to your equipment, with reference to your particular distribution network, and individual power demand with reference to your entire distribution network. So individual power demand you can see in summarized form. What are the power profile? Means as discussed, daily load curve, monthly load curve, and yearly load curve. This is why required, because you have to analyze your daily load pattern, your monthly load pattern and yearly load pattern. According to this analyzing and data analytics, you save your energy consumption and reduce in your carbon footprint. This is the power demand analysis in different types of the chart. This is daily load curve with all parameters, and this is the monthly load curve. Here you can see some seasonal effect in terms of the summer season and monsoon season, some of the peak of the power demand. So this is the typical snapshot of particular software which we are using in building energy management system. What are the building energy management system application? First of all, public facilities means school area, sport centers, and health centers. All in colleges also, in your campus premises also, you can use or design building energy management system. Commercial buildings, offices, hotels, shopping malls, retail, and chain stores. Industrial premises, process plants, small size plants, and mid size plants means small scales of the industry. What are the application factors you have to apply it or you have to keep in mind when you apply building energy management system for particular area, industrial premises or commercial premises or public facilities? It must be simple, integrated architecture, flexible, customized with reference to your application, optimized, yes, it is most important, efficient, it is also most important, and reliable, easy to control. So this is the all types of the application factor you have to keep in mind when you design or apply building energy management system for particular application. What are the different application and network building related to building energy management system? Here you can see sub metering and branch monitoring. Here you can see this is the main system, web-based server, Ethernet switch, and this is the master metering. This is sub metering to analyze sub power distribution or sub power demand. You have to maintain your entire parameter, water gas. This is the all means within this all sub metering and branch monitoring, you have to maintain or you have to operate or analyze sub branches and sub metering in your building energy management system. Retrofitting and upgrading of the building, you can do some improvement, R&D, retrofitting of the power distribution network within your building premises, or you can upgrade your power energy demand or upgrade your electrical equipment, electrical network diagram, and this is the part of retrofitting and upgrading of the building. And last is a industrial site, how to maintain your entire distribution system as a local operation and remote mode operation. So this is the different applications with related to network building in building energy management system. This is the design to operation and complete solution. First of all, values proportionals, design and specification, installation and operation. So simply you have to manage your building energy management system at your design and specification level, at installation level and operation level. Here you can see speed up your project, increase the facility value by 5%, reduce investment in supervision system by 15%, achieve compliance of higher class of the energy efficiency standards, faster payback. Means you have to keep in mind this parameters when you design or specify your particular equipment and distribution network. How to install, easy to install, connect to the cloud in the only 10 minutes, reduce cabling by the 60% with the application of fiber optic cable and cloud based network. Upgrade in one day an existing installation, upgrade with zero component replacement in the existing installation. And how it is operate with energy efficient system in energy efficiency mode. Save up to 20% on maintenance cost because it is a operate as a optimized condition. Save up to 20% on energy bill because why it is save, because when you operate as a maximum optimized and operation condition, get protective alerts and guarantee operations in 1 minute, remove energy efficiency by up to 10%. So this is the complete solution, means entire system you can operate, manage and design with this application in building energy management system. Case study, typical power demand. This is the four pillars. This typical power demand and case study for the building energy management system. Demand calculation, calibration factors, diversity factors, demand summary, and distribution network. Here you can see some typical flow chart procedure of the demand calculation. How calculate your demand in a particular building premises. You have to identify your length and width of the building, particular total area of the floor, per floor power demand, what are the technical equipments room exist or not, if exist then what are the calibration factors and demand factors. According to this building process, the building demand calculation procedure, you identified or you calculate your demand calculation with reference to your different types of the application, either it is residential, commercial and industrial application. This is the calibration factor calculation. This is different six types of the calibration factors which you have to apply in building energy management system. Means building placement, KPLC building placement. How building placed in your particular plot area, it is a in wind direction or it is in placed is a sun direction, is a in front of the sun rise or a sunset, it is a factor of building placement. Room structure, how you design structure of the building depends on k structure calibration factors. Comfort level, what are the comfort level you provide in your building premises. Means it is a operate, all equipment operate only manually, automation and control, or both manual and automation and control. So this is the part of comfort level calibration factor. Air conditioning option, it is a covered in k climate calibration factors and technical characteristic. It is a, if technical building available in your building energy building premises, yes or no. And last calibration factors with reference to building automation and technology building management. So these are the particular calibration factors as per particular European standards. You have to apply this calibration factor during the design and specify of the building energy management system. Here you can see typical demand calculation for bank area, shopping mall, medical center. At the end of or follow procedure of the power demand and load flow of the power demand. At the end of the calculation, you can found wattage per square meter. What are the wattage per square meter in bank? So this is the 5.6 wattage per square meter in bank. You have to calculate power demand. In shopping mall, 41 wattage per square meter. In medical center, 95 wattage per square meter. This is the all are the typical values as a demand calculation in different area. Here you can see in office premises 37 wattage per square meter. In hotel premises 41.5 wattage per square meter. Underground parking area 5.6 wattage per square meter. So this is the typical demand calculation for our public buildings and utility buildings. Here you can see a procedure of load flow analysis. What are the procedure of load flow analysis? You have to check your power flow network within your requirement or not. If not, then you have to import more power, or you have to manage your power quality or voltage profile within your load flow analysis. Power demand and diversity factor. What are the diversity factor related to your hour basis? Means in morning, afternoon, and evening. What are the power demand and diversity factor? Perform load flow and analyze the behavior of the distribution network to maintain voltage profile at load bus. Control operation and control philosophy for energy management system using SCADA system. What are the check system behavior? Under voltage condition, normal voltage operation, and over voltage condition. You have to identify your power demand and diversity factor. Here you can see total power demand for particular building. These are the particular building premises: car parking area, technical equipment room, data centers, bank, storeroom, shopping area. Store means particular normal stores, mostly available in first and second floors in public utility buildings. Shopping malls, medical center, event center, office, hotel, technical equipment room, technical equipment, refrigeration and ventilation. Here you can see a total power demand zone wise. This is the diversity factor. After the application of diversity factor, this is without diversity factor application, total power demand is 28 MVA. And after the application of diversity factor, here you can see the decrement of the power demand. Here you can see, and so morning 1727 MVA. During the afternoon condition, it is a 23 MVA. And during the evening, 20 MVA, and during night condition, it is a 13 MVA. So here you can see this is the actual calculated power demand, and this is the operational power demand after the application of diversity factor. What are the power demand summary? Here you can see a difference. Here you can see a difference. This is the total power demand. Zone wise means particular area wise, data centers, event, data centers, then banking, hotels. This is the zone wise power demand. After the application of the diversity factor, here you can see the difference between the power demand. This is a typical distribution network as a radial feeder. In radial feeder, this is the three features: single source of supply, no contingency level, no reliability level. Here you can see this is the single radial feeder coming from the power source. This is the main incoming bus, and then three circuits indicate in this power distribution network. Again, in the one circuit, again distributed in the three more circuit. Here you can see in second source, main circuit, three sub circuit, and this one circuit, one circuit, and this is the sub distribution. Here you can see each and every circuit and each and every equipment, only one source of supply available. So there is no any contingency, or there is no any reliability level provided in this planning and design in as a radial system network. Here you can see a typical ring feeder. This is the features: multiple source of supply, n-1 and n-2 contingency level provided. highly reliable. How it is highly reliable? How it is provided? N minus one and n minus one two contingency level. Here you can see this is two source of supply. If this source is not available in mal operation or any maintenance condition, so you can feed power for particular this network from source 1, or source 1 is not available. During this condition you can feed power for particular this network from source 2 in this direction. So this is the n minus 1 contingency, and this is n minus 2 contingency and reliability. If this one or two transformers distribution transformer not available, either it is in condition faulty condition or in maintenance condition, then you feed a power using this distribution transformer via this bus section or bus coupler. You can feed either this feeder or this feeder using source 1 and source 2. So this is the beauty of ring feeder as a features of n-1 and n-2 contingency and reliability system. This is the one view of comparison of radial feeder and ring feeder. Here you can compare. This is the single source, multiple source, no contingency level, means no second source of supply, no any reliability during faulty condition or maintenance point of view. Here you can see n-1 and n-2 contingency level provided and highly reliable system. As discussed in first slide, in 2050, our power demand doubled or two times in 2050. Why? Because of e-mobilities, bus charging, small charging system, multiple charging station, fast charging system, domestic charging, one solar, one world, one grid, wind power, and carbon emission reduction. With this all application, because of fossil fuel and non-renewable fuels, non-renewable applications, we have limited source of supply. That's why we have to depend our natural sources of the power like sun, wind, tidal energy, biogas energy, and these all energy sources are our future. That's why we and government or public state utility and central utility imposed us to using e-mobilities. This is the small video. Here you can see our state of art power ABB Power Technology Experience Center at Vadodara Manager location. And this building entirely operated by building energy management system with state of art technology. Here you can see automation, building automation and automation controls within our building. This is the state of art technology as building energy management system. Thank you so much for be here and be patient with this webinar flow on building energy management system.
Thank you very much, Keval sir. Currently, I have received one question. The participant
Desai and entire Parul University and
Hello, Keval sir, am I audible?
yes, yes,
Yeah.
you are audible. Please
A
continue.
participant wants to know about this sunblind control. In one of the slide, you have mentioned about the sunblind control.
Yes,
So
yes,
the
yes.
participant wants to know about
It
that.
is a sun. It is a one type of the sunlight control. According to the sunlight detection, your curtain application open and close with reference to your particular sunlight and present detections within the your premises. So this is the sunlight control.
Okay, okay. So currently, sir, I have received this one question only. Later
Okay.
on, if I have received any question, I'll forward it to you. So you can just send me the reply, and I'll forward it to the concerned person. So that's what
Okay.
we will do.
Okay. Okay. Thank you.
So,
Thank you so much.
thank you very much, Keval sir. I, Ishan Desai, and Professor Richi Patel, on behalf of Electrical Engineering Department and Parallel University, thanking you for your precious time and knowledgeful presentation as well as this fruitful session. Definitely, the participants were able to know so much things from this particular session. So, thank you very much again.
Thank
Thank
you,
you very
thank
much.
you. Welcome you all, and thank you once again, Parallel University, for giving me this opportunity to share our state-of-art technology with uh, expert talk on building energy management system. Thank you once again.
Thank you very
Bye,
much.
bye.
Thank you.
May I leave now?
Yes, sir, you can. Thank you.
Thank you. Bye, bye, bye.